So the first team up is Ben, Francisco, and Vinicius.
Yeah.
All right.
That sounds like team amazing.
Let me share my screen because that's the biggest contribution for this hackathon. It's doing the presentation.
Oh, I thought it was just gonna be sharing your screen. That's it.
Yes.
Okay.
Oh, okay. Are you seeing my screen?
Yes.
All right.
Team Hacky Hackers.
So yeah, it's a suggestion from Ben, and just actually the only one suggestion we had, so it was automatically chosen. And our project is Spring Hello World on Kubernetes. So what the problem we were trying to solve here is, oh my God, my websites are not containerized. So that's the biggest problem we are solving here. And our initial plan was deploying a Hello World app in Kubernetes. Actually, we were thinking about something with Spring or something with React. In the end of the day, we are doing Spring. And yeah, demonstrate some Kubernetes features such as load balancing, self-healing. That was our initial idea. Not exactly what we accomplished. Yeah, the technical approach is first thing, having the Kubernetes run in the local machine, then migrate the images and containers to the cloud, Docker, ECR. Then finally run the Kubernetes powered image on AWS EKS. And yeah, implement as many Kubernetes features as possible. And then take the tail nodes to ensure a sync team and easier debugging. All right, some obstacles. AWS account setup that took a long time in the beginning, setting up services and roles. Then configuration for EKS clusters, ECR repositories, VPC, and ECS. Other obstacle, little knowledge and experience, a lot to learn. In my case, zero knowledge and experience with Kubernetes. Several outdated and faulty tutorials. And yeah, other projects running. So that was an obstacle to work on the project. Ben, anything else? Ben, Vinicius, around obstacles?
No, that summarizes all the problems I had.
Yeah, me too. I focused a lot on several outdated tutorials. Very hard to find some good sources nowadays.
All right. And let's demonstrate what we accomplished. We have a print screen here, but let's demonstrate the thing working. I'll stop sharing. So let's see Ben, right?
All right. I'll get to show off the live thing, which is much more interactive than screenshot. All right. Close off all these other windows. So here we have something that looks a lot like the screenshot, but it's live. So what we have here is a local Kubernetes container. So I'll have to go ahead and type some commands to get that up. It's a lot faster to run this locally than it is to hit deploy on Amazon, wait a few minutes. Kubernetes control, create. Oh wait, that's the wrong one. I need to do Kubernetes control, port forward, XZ demo, port AT. And over here, localhost, it says hello world.
Wow.
It was much different than the screenshot. So,
Yeah, and so Ben, why people want their website to be in a container?
So containers are really good because they're a lot more standardized in how they get run, and it's easier to move them around to other environments. For example, a development server or a testing server, or even on a local machine like I'm running now. And putting it in a container makes it compatible with a lot of other features that Kubernetes has to offer, including load balancing, self-healing, and a whole lot of cool tricks. Unfortunately, I wasn't able to show off a lot of those features, but I was able to learn as much as I could, and I really enjoyed that.
All right.
That's good to hear, because your next 5 projects are going to be full-time Kubernetes orchestration. Then
I've got a 2-day head start.
there you go.
All right. Yeah. We got some wins, success here. So I'm not saying nothing about, because I'm just helping my team with trying to make them motivated. That this is everything I did here. So let pass to the technical guys so they can say more concrete things about wins and successes.
Let me go over that part just to participate a little bit. So our wins and successes were, we learned a lot about local builds with Kubernetes and containers. We gained some experience with some AWS services like ECR and EKS. Even though we weren't able to deploy, we learned a little bit about troubleshooting, a little bit about how to connect with AWS and stuff. Ben was able to create several nodes on the local builds that will probably be able to translate into a blog post, and also understand good understanding of AWS ECR to use it as a repository. So it was pretty cool. I particularly learned a lot about AWS, Kubernetes, and even forgot the other container name, Docker, and a little bit about Docker too. So for me, it was pretty cool.
Nice. So are you ready to be a technical lead for Kubernetes implementation? I think so, right?
In my own projects, probably.
All right. Okay. So yeah, we have some lessons learned here. I'm gonna pass that to Ben.
All right. So the first most important lesson we learned is there is a lot to absorb for just a few days. It was a lot more than we were prepared to take on. And we got as far as we could have. Another lesson that we learned firsthand is just how complex cloud applications are compared to local applications. Hence why I had a local demonstration rather than a Amazon powered presentation. And one of the reasons for that is a lot of the documentation and tutorials we read wasn't able to help bridge that gap in knowledge. There was a lot of instances where we had to jump between different tutorials, or it was using a older version of AWS libraries. So there's really no shortcut to just learning. And the last lesson we learned was how our time and project constraints have to be factored in, because there were still a few meetings here and there, so we weren't able to dedicate the entire day to learning. And those were the important ones. All the other lessons are things I mutter under my breath, not for the slideshow.
Right, Ben. Thank you. And that's it. Any question, guys?
So did you do a deploy to AWS and it just didn't work out?
Basically, yes. So we were able to get all of the nodes and clusters running, and we have the image on the repository, but it just never returned anything when we loaded up the IP address. So
Okay.
just a little bit of debugging, and then we'll have a working installation. So
Okay.
Almost got there.
Hey, hacky hackers, good job. I noticed you used the term K8. Is K8 the same as Kubernetes, or are they different?
Yes, K8 is a short spelling for Kubernetes. The 8 stands for how many letters are removed in the acronym.
Yeah, this is a thing I learned, right? I didn't know about it. All right. Nathan, any tricky questions for the team?
Well, not to spoil anything, but I'd love to see a list of the blogs you read. I'm sure we read a lot of the similar blogs that were out of date. So I'd love to see your list so we can compare them and then harass them online, because that was really, really annoying. Also, how would you recommend this going forward to clients as part of a technical solution?
I think I would still recommend Kubernetes as long as we allocate enough time to set it up, because I think the long-term benefits are worth any short-term hassles.
Cool.
My opinion is that Kubernetes is not for every project. You know, it has so many features that a small project is not going to be able to use or even start to get to know. So I think Docker still solves the majority of problems for smaller projects, but for big ones, I think Kubernetes is very, very cool.
Are there any types of clients that Kubernetes would be good for? Any existing clients or any future clients?
I think Kubernetes would be good for clients who have a lot of web resources, whether they're interconnected or whether it's a lot of separate websites and services, because that way that would remove the chance of one part of the website crashing the rest, thanks to the nature of the self-healing features of Kubernetes. I don't know which existing clients off the top of my head would benefit from it, but I'm definitely going to be thinking about that more moving forward.
Great. Well, thank you, happy hackers. Everyone, let's give a round of applause. All right, next up is me and Laura. I'm going to share my screen as soon as I remember how. No, that's the wrong share button. Present, that's what I'm looking for.
I love the name.
Thank you.
Hello,
so Laura,
everyone.
Take us off?
Yeah, I can start off. Hello, everyone. Our team is going to talk about kubeless, which is a serverless version of Kubernetes. So our team name is called Lipin Loboguará. Can click. So we named our team out after the Brazilian rare animal. And funny fact about that, it's printed on our new 200 bill in Brazil. So there's only animals on our bills in the Brazilian currency. And the last one was Lobo-Guará. Click.
It's the right color of orange, so that's good.
Completely planned that way, Tony. Yeah.
It's a rare, yeah, it's the right. I'll show on the final slide what color is the animal and what color they choose for the bill. I didn't like it. Okay, so the project consists of creating an instance of Kubeless, and we are dumping data from a data stream, and these data streams comes from a smart city application. So I'll show you in a few slides which application is it. And our aim was to build out a function as a service stack. So this is the main goal of building a Kubeless cluster. So we were trying to build a fast stack. So our aim was also to build a data API using Kubeless. So we were trying to push the data into a database, which is I don't remember what's the name.
DynamoDB.
So DynamoDB. Sorry, I'm a little bit nervous, but yeah. And we are also trying to pull data from it. And also our aim is to scale functions on demand. So as soon as the CPU usage increases, we build out, we scale the amount of functions. Click. So our technical approach for the hackathon project was to use the command line as much as possible, because we were trying to build knowledge around Kubernetes, and we were trying to drift into applying config files for some elements. So we had to look on the config files and try to learn the most of it. And we were trying to build out modular functions, and we had to deploy it locally to test it. And then with a Kubeless function call, we use the Kubeless function call to deploy it locally, and then we move that to the cloud. We also had a proxy to test via API and move to the AWS EKS service. We also had to learn to get the pods to auto scale. So that was a tricky one to learn. Click. And most of our obstacles, I think the hardest one was getting Kubernetes to work on my Linux desktop. So we spent one day trying to do that, and it didn't work at the end. And we installed the stack, but when we were trying to call the function, it didn't respond. But when we moved that to the cloud, it did respond. And we also used Ingress and the application load balancer to AKS. We tried to use IAM roles, but some of them were out of date and didn't work. But at the end we made it work. And yeah, the Kubeless functions, they don't outscale. It's because I think it's because it's not supported on Kubernetes. So we had to use the kubectl command to auto-scale our functions. And one of the obstacles, the last obstacle, was to see Kubernetes pod resource usage, but we get it to work on Datadog. Click. So now what we're gonna do, can I have the screen, Nathan? I can show you our.
Yeah, real quick before we kick this off, you'll notice down here on my screen, we currently have one post pod, and we're gonna hand it over to Laura to kick off a bunch of data coming in. And when we come back, we should have a lot more.
So what I'll do now is I'm gonna run the smart city application. So we can see that I think it's a real scenario from Bologna in Italy. So we are creating a data stream here. So I'll play, and you see like the cars coming like from that junction, and it's generating the data stream. So we can see it here, the data stream going to the database. Sorry. So I'll hand it up to you, Nathan, so you can keep on.
All right, let me share again. All right, so first off, it hasn't scaled up yet, but we have all the data coming in from Laura's test here. You can see that coming in. And then I'm gonna come over to our cheat sheet. And we're gonna pull some data from a specific car. See how quickly that comes back out of there. We can see the data coming in just directly from the DynamoDB. And then I wanna get a list of all the cars that are coming in. So we have an endpoint for that returns all of the vehicles. And if you look over here again real quick, you can see we're turning on new pods. The CPU is high enough, long enough, it's going to turn on new ones. And it takes about a minute, I think, for those to come into circulation.
Very
And then
cool.
we have an endpoint to get, if I copy it correctly, get all the cars on every road. And then lastly, we have one to get the cars for every speed over a certain kilometers per hour.
So these are the cars that should get a fine, for instance.
Is there a lot of transformation going on with that data set? Or is it just
These
straight
are
up?
pretty raw coming out of the database. I think the most we're doing is a little bit of filtering after it comes out of the data set at this point.
Okay.
Awesome. Well, let's go back to the presentation. Laura, you can stop the simulation then if you'd like.
Okay. Just stopped.
All right. So going on, wins and successes. Very quickly able to push and pull data from the database with these functions was really, really nice to see. I was really disheartened when we couldn't use the built-in kubeless autoscaling, but so we leaned back into the Kubernetes horizontal autoscaling.
And that was just a versioning hiccup?
That was the GitHub. We found two different GitHub articles on it, and it worked with Kubernetes 1.12, but 1.13 it started to break, and they're on 1.18 now, and they haven't fixed it.
Oh, okay.
So, but the Kubernetes built-in horizontal autoscaling worked great. Then being able to use a single elastic load balancer to route to all the different pods, so it's all going to a single HTTP endpoint, and then that faces the route.
That's cool.
And then since we couldn't tell if the autoscaling was working with kubeless or not, we needed to find a way to monitor the container CPU, and we got Datadog installed and running on it, which was pretty cool.
Are your sessions sticky so that you hit the same pod for like using a cookie or something, or are they idempotent so it doesn't matter which pod you hit?
It got load balanced. I was happy. I didn't look into it too much, honestly. Lessons learned. So Laura's problem was getting his local environment. I think I spent 8 or more hours getting the load balancer to route traffic correctly. And get it to set up.
Laura, you're on Linux desktop.
Yes, Linux Mint, 19.3.
You are hardcore.
It's because I got more like performance out of Linux.
No, you say yeah, I'm hardcore. Yeah.
So next time we ever did this, I would not use the command line or use this. I'd switch to Terraform. Terraform has classes to manage all your Kubernetes stuff. So I would try to do it from that instead. Hopefully obfuscate a lot of the little things we had to run into. I hit a lot of those same bad articles for ALB and EKS. And the gotcha I have found was not in the articles. It was on a blog post. When you create an EKS stack from the command line, like everything tells you to, it doesn't actually tag all your subnets correctly. And once I found that little gotcha about the tags, we added the tags and just started working.
Right. Oh, look at that.
Was that it? That was it. Yeah.
Yeah, we're
Any
not
questions?
giving money to anyone who asks questions,
So who gets the 200?
Nobody here in Brazil has.
Yeah, actually, it's rare, such as the animal.
Oh,
I have a question about
Yeah.
load balancing. Was there any particular thing blocking the load balancing from being set up, or was that a normal amount of time?
Oh, it was, I think I hit 4 or 5 different articles on how to set up the load balancer properly. The 2 biggest gotchas I came into were none of them had their roles set up for the current version of Amazon's IAM. So my current role is disgustingly permissive at this point and would not pass in a production environment. And the second one was those tags. As soon as we got the tags, we could see that they would be mounted. Otherwise, you just get an error saying can't find appropriate subnet.
Okay.
is that? It seems really buggy. It can't be a feature.
What, that the tags are there? I'm actually a little surprised EKS didn't apply the tags by default. It might have been that there's a flag you have to put into the command to do it. We were using the pretty basic like EKS cluster create and a name, and it just like out of the box creates a cluster. So
Yeah, that's reasonable. Okay.
yeah. And if you're really doing this with Terraform or something, you'd be able to just look and apply all your tags to everything
Yeah.
across the board.
Wow. Okay. Darn it, tags. Cool.
Any other questions?
Bob, you had a question about Terraform clusters, right?
I think he fainted, Joaquin.
All right.
I had a question for you. Sorry, I had a question. I was waiting for another question. I noticed that there's people are comparing kubeless with lambdas. Is there a reason why you would choose one over the other, and what's the advantage?
I would never recommend kubeless over lambdas. In fact, I'd recommend you always use a cloud rolled CM function as a service, because you don't have to worry about any of that engineering behind the scenes. But for instance, you have an on-premise data center, or you have regulatory requirements that you can't use it, or organizational requirements that you remain cloud agnostic. This would allow you to roll your own and use that same sort of feature.
Great, thanks.
All right, I will stop sharing. And last but certainly not least is Michael, Nadia, and Ali.
Hi, let's see. What do I got for you guys? Well, here's my Teams conversation, and there's my calendar, and here's a presentation. All right, so we are Heavy Frog, as in heavy on the frog. And we built, and when I say we, I mean David and Nadia built this badass way of being able to test.
Ahem.
It's called Distro LT. What we did was the problem we were solving is, how do we perform load testing and save time? And it has to do with, manual versus automated, but distro T works like this. You can use containers and test servers to run multiple containers. For our demo, we used a queuer to run the tests, and the tests go from boss to workers. And it's using Kubernetes and a built-in tool which clusters, so they can find and talk to one another, so the containers can talk to each other. So you can run lots of little tests or really big tests, and then you can distribute it out through those multiple containers. Kubernetes allows you to create a distributed framework, so we can deploy to anything like AWS or Azure as far as some kind of cloud infrastructure. And you can run lots of tests or lots of little tests all at once. Bam. For the technical approach, we use JMeter to run it, Docker to store, and then Kubernetes is the service. We ran several tests, and the several different tests we ran were response and reports on response time, checked for percentage of errors, average response time, active threads over time. And special thanks to David Dolan. He provided us an API to a website, www.juice-menu, for us to run these tests. So we ran 2 minutes of tests with 10 users and 2 pods of those 10 users, which actually equals out to 20 users total. Where our gotchas were. So it took 6 tests to finally be successful. And what the common denominator in the tests were the configs from JMeter. Time, obviously, I think is everybody's challenge, but that's the fun of having a hackathon, like getting as much as you can with the time that you have. We had a huge learning curve as far as Kubernetes is concerned. And I quote, JMeter, it's a big, ugly, hairy Java app. But it's a really big functional tool, and most of the time functional tools don't have simple ways to use them.
You really don't have to say big, ugly, hairy Java app. You really can just say Java app, and we all know
exactly what you mean.
Yeah, exactly what's going on. Like, we all know.
But the cool thing is it's open source and it's light and easy to run on our personal computers. It's free. Other more fun tools are a little spendy, so JMeter is free to use. So that was a highlight.
Well, just so everyone knows too, that JMeter is a common tool for Metal Toad. We use it all the time on our customers.
And on that note, I'm going to pass it over to Michael and Nadia, the true stars of the show.
Nadia is the one who came up with the idea of doing distributed load testing and distributed API testing. So Nadia gets the credit for coming up with the thing, and then I just tried to make it work on the back end once she got the front end working. So all hail Nadia for coming up with the idea.
Yay.
So I'll let her talk about it.
Michael. Thank you, Michael. But you happened a lot, actually. You happened that you actually made it happen. So thanks to you and Ali for helping this presentation. I want to give you an overview about JMeter for those who are here and doesn't have an idea of what it is. So this is how it looks like. So yeah, it's a Java app. And in here, we can set up the users. We can set up the time that we can test in a website. So talking about loading testing is all about performance. So I know everyone here. Yeah, so I know everyone here experiencing in a website, we go there and start loading and nothing happens. So this is a performance issue. So we can do this with JMeter. We can break a website. So to show that to you, I'm not going to perform because I already have the results. But basically, I got the file from the JMeter, which is JMX. And I performed a very simple test in the endpoint that we have, that David had for us, which is juicemenu.com. And this is just going there and going out, just this. I tried with Metal Block, but I was afraid to do that. So I didn't want to risk 100 users there.
I've done
So,
2,000 against Metal Toad. It's fine.
Yeah, bring it on.
2,000.
Yeah.
No. The response time for clicking in blog was too much, so I didn't want to show that. So okay, so moving on, I added some reports for this testing. So first of all, we have 10 users for this testing, very low. The wrap up period is 60. That means how much time the user will be there. I don't know, will be in the website. So we can have 10 users at the same time for 1 minute. And the duration, we wanted 5 minutes, we wanted 10 minutes. We will go just with 2 minutes. So we had to run some testing, and we didn't want to be like 10 minutes waiting for the results. So basically when I run it, I will see the graphic going up. So this is the number of activity users. So 1, 2, 3, and then to 10. And they stayed there for like 1 minute into the website. And with that, we can see how much the time that the user is taking to open this website. How much is it? Like 8 seconds to open it? When I tried with 100 in this website from David, well, like 40 seconds and higher. So poor David. Okay, so this is the test that I did. So I was thinking if we could do this low, because when I send this file to Michael, when he runs in Kubernetes, what we will have is a master one, and we'll have some layers, some pods that once we run it together, it will not run 10 users like my test. It will run 20. And this will report to the master one, which is the boss. Michael will explain that better to you, but this is what I learned, and I'm really happy about it. And yeah, it's basically that I saved this file with the configuration for this testing. I sent to Michael, and we did a couple of testing, and now he's going to show to you how it's working. It's on you, Michael.
Thank you. Let's share screens here. No, I don't need it. All right, so before we get started, as with any demo, there's always the possibility of something going horribly wrong. So let's show you the previous demo just to prove that, yeah, we did actually get some results. So here's the last, here's the working area. This will be running on my machine because the idea was to get it running locally. And then if we had time, push it out to Amazon. Kubernetes being Kubernetes, yeah. Plus we had to deal with Java with JMeter, which I'll be honest, we had planned on using a different tool, but it didn't really do load testing. It did API testing, and it was more of a API coverage tool as opposed to a load tool, which would have been easier to implement, but didn't really stretch Kubernetes at all. So this actually shows a little bit of the clustering. So if we do results, you can see we got a previous report out of it and some other stuff like that. So it does exist. So the first thing I'm going to do is build the environment. So we had to grab Kubernetes, or sorry, we had to grab a copy of JMeter and get it working in Dockerfile. As with everything else, we first go to the web and check some tutorials for how some other people have done it. The net result was we get a local Docker environment and build the container. If people are interested, I have the Docker file here. It's plain old Docker build stuff. So once we do that, now we got to have the Kubernetes environment. Going to run 3 different pods. Worker 1 and Worker 2 are meant to just kind of hang out and work for a while. They are stateful, and they will also restart themselves if you kill them. So I'll just show you those right now. So these are now running. And I can kill them. Come on. So it already restarted itself. Still terminating. So once this finishes terminating, there we go. Creates another container right off the bat. So if one of these things died due to something going wrong internally with JMeter, it would come back up. Okay, it's back up and running.
Quick question, Michael. Is that a function of Kubernetes or?
That is a function of Kubernetes. And in particular, it is a function of it being a stateful set. So, and a service. So let's look at how that works. So we created a stateful set. A stateful set is basically, a lot of the time you build these things and containers come and go and you don't care about their internal state. In this particular case, we want to save state on these containers because they may have something we want to keep. And if one dies, we want to hook it back up to what it was working in, so we don't lose work. So what the stateful set container will do is it will reattach to anything it was building, in particular this volume here, which I'm using to save data in, and also logs, so that if it dies and it restarts, I still have whatever it might be. If you had something that had local information on a local volume that you didn't want to lose because it was pretty expensive to create, you might use a stateful set. Okay. A lot of other services, you just kill them and they come back and you don't really care what happened to them. So the important part here is that I have two workers, each running, each will come back and running, and I could scale these out, but we'll just do two because that was a start. And now we have the boss. The boss is basically going to go tell these guys what to do. This uses the same container. That was important so that I didn't have to maintain two different containers for this. And all it does is it says, I'm going to give you, based on an environment variable, I'm going to run the command slightly differently. In this particular case, I want to run this JMX config, which is heavy frog, and I want you to go and do it. Okay, so to start it all, it's the same thing. And I will just get the output of the boss because that's where the interesting stuff is happening. The first thing is it's going to do is it's probably, at least once it finishes installing itself, is it's going to clear out. So it's basically installing some stuff.
You can't do anything with -F follows, just so you know.
Yep. And the -F clears it. So it should, yep. So you'll note that it has nuked the previous versions, and now we'll get the output. Okay. So start your remote engine. So it's basically talking to them and is running the thing now. And we get 2 minutes to wait. So while we're talking about 2 minutes, this took me a while to get to, not least because had to, again, like everybody else, understand what's going on. And then we had the other half of, instead of just throwing up a web app, I had to get JMeter to work correctly in Kubernetes and find the things, how that worked and so forth. So that was interesting. Some of the things that we had wanted to do that we're not going to get to do was hook JMeter up to a backend like Grafana and have some nice graphing of the results. One of the other things I found people were doing was they were putting it into a CI/CD where basically you would hook it up to Jenkins. Anybody remember Jenkins? And basically talk to a running load balancer cluster or running Kubernetes cluster of, hey, could you go load test this for me? And it would go and load test. So let's see how we're doing. Okay, we have the results. And now we have all of this information here. You can see information coming off of more than one worker. So this worker did that, and then we'll look for worker 2. Here's worker 2, and it did its stuff. So both of the endpoints did work. So it definitely acted like a cluster. And it's done. And then we could, if I want to, I can kill and restart this. One of the things I wanted to do is basically get the boss node hanging around so you could just hand it new JMXs and have it run, but ran out of time. But that's where we stand. Not as graphically pretty as I wanted, but it does do work. If you poke it, it does work, which is all I really cared about. So the next thing we do would be to upload this and run it in an Amazon or Azure Kubernetes cluster and hand stuff off to it. Any questions about the Kubernetes side of things?
It's a good demo. Thank you.
All right. And now Tony will probably demo something to blow us all out of the
I
water.
know.
I'm just going to demo my appreciation for you toads. Just demo and love. Clearly, that's all I'm demoing today. Just thank you. It was awesome. All right, Nathan.
Were there more slides, Ali, or was that everything?
Or a couple more, but I think Michael pretty much covered it. I mean, we can. You know, wins and success. You know, what are our woohoos, wins and successes? Excited to learn about Kubernetes. Got a feel for how it works. You know, how the containers work in Kubernetes, and then learning cool things about JMeter that they didn't know before. One of the unknowns was, can we work it in a distributed fashion with the virtual service? And then moving on to lessons learned, Michael covered that too, I think, as far as like, they wanted to, if there was more time and like any other hackathon, they'd have more better chance of learning more about it and expanding their creative knowledge. But one of the biggest things, which I started looking into and honestly just didn't have time to make it happen on my end, but we wanted to deploy it to Grafana, and then Grafana show this really cool dashboard of the tests running and everything. And these are the, percentage of errors and what were the active threads in the response time. And so that's what we were hoping to show, which would have really been the mic drop moment. But, that mic drop is going to happen in a future version. And those are our remaining slides.
Well, I'm hoping that there isn't a DDoS that can be traced back to this code that you guys wrote.
I was just going to ask for my question. At any point, did you bring David's test site down?
Oh, we hammered it into the ground. We had to back up. One of the things we were doing was busily backing off the number of threads, because when we hit 44 seconds to service a thread, it was not great.
I tried 100 users and just went down. And David was, oh man, I'm seeing you guys. I'm seeing what you're doing. And he asked if we wanted to pump up to get the provider higher for the website. We said, no, let's leave it like it is. The graphics looks nice.
This is one of those examples where a hackathon and alcohol do not mix. Awesome.
Any other questions for Heavy Toad?
Heavy Frog.
Great.
Great. Well, thank you. And unfortunately, Tony was unable to participate this hackathon. He'll be back next hackathon with something bigger and better.
I'm saving up my limited cognitive resources to do even better next time.
And that's all the demos. So thank you everyone for participating. I look forward to reading everyone's blogs on the webpage. So have a great Friday, happy weekend, and thank you for the hackathon.